Hello dear students, this is the last lecture in electrochemistry chapter, this one lecture 10. Let's start our conductometric titration concept. Conductometric titration. Over titration, how conductance of solution observed is nothing but conductometric titration. So titration in which end point is determined by measuring conductance. So every ion have a specific value of conductance, depends on the hydration enthalpy and velocity and current carrying capacity. This conductance value is decided. So the order of conductance will be this: H plus greater than OH minus greater than Br minus Cl minus and K plus, and nearly same with Ag plus, nearly same, not exactly, Na plus and Li plus. So this is the order of conductance of ions. Based on the presence of these ions over titration, we can decide conductance of the solutions. So the first case, titration of strong acid with strong base. Strong base. So conductance and volume of alkali added. We know that how to conduct titration. Generally we take base in the burette and acid in the conical flask. Slowly we add drop by drop base to the acid. During that, what happens? So initially strong acid present in the conical flask. Since it is strong acid, the ions are more, or the dissociation of acid is more, so that conductance is more at initial time. Generally you take HCl versus NaOH. So HCl is having H plus and Cl minus ions, both are having high conductance value, we can see here. Strong acid, strong base is HCl is strong acid, combines with NaOH and get NaCl, which is strong electrolyte, H2O is weak electrolyte. So over this process, Na plus replacing H plus, that H plus combines with OH minus and making as weak electrolyte as H2O. So in this case, Na plus is having less conductance value as comparatively H plus, so that the conductance slowly decreasing as like this. So this is how the conductance we can get. This is how we can get the conductance over decreasing, and this is nothing but equivalence point where acid equivalence equals to base. So later this will, what happens after reaching equivalence point, we keep on adding NaOH to the solution, so that NaOH is strong electrolyte, so that strong electrolyte also produce more number of ions or increasing concentration. That's why the conductance will rise as like this. This is nothing but conductance versus volume of alkali added in the titration of strong acid with strong base. Hope it is clear. Coming to the second case, that is titration of weak acid plus strong base. Weak acid plus strong base. So in this case, we can take example of weak acid CH3COOH, strong base is NaOH. Over this reaction we get CH3COONA plus H2O. So in this case, this is weak acid. So conductance of weak acid less at initial time because dissociation is very less, and volume of base is added here. So initially the conductance value is less because of less dissociation, and slowly increases because here this NaOH causing dissociation of weak electrolyte more and make salt CH3COONA. So this is having more dissociation power as comparatively CH3COOH, so that it is keep on increasing and reaching to the equivalence point. We can also add buffer concept here. And finally, what happens after reaching equivalence point, NaOH will keep on adding so that the conductance keep on increasing, because NaOH is strong electrolyte or strong base. It give more number of NaOH and Na plus and OH minus ions. That's how the conductance is keep on increasing. Coming to the next model, titration of strong acid with weak base. Strong acid with weak base. Example for this, HCl reacts with NH4OH and get NH4Cl plus H2O. So here initially strong acid is there, so conductance of initial solution is more. So here initially strong acid is there, so that the conductance value is more, and after reaching equivalence point we are adding weak base so that the dissociation of weak base is less, so the conductance is not sharply increasing, just like increasing as comparatively equivalence point. Suppose if it is strong base, it will be like this. That's the difference between weak base or strong base over addition. Coming to next, titration of weak acid and weak base. So weak acid CH3COOH, strong base NH4OH gives CH3COO, NH4 plus and H2O. So here we are taking weak acid first, so that conductance of starting solution is less, so it will be like this, and over addition of NH4OH it increases, but after reaching to equivalence point, here we have to understand one thing. CH3COOH is weak acid. Without other help, it will not dissociate much. When NH4OH is started adding, the dissociation of weak acid keep on increasing, so and increases and reaches to the equivalence point. So CH3COOH is weak acid. When we started adding NH4OH, the dissociation of weak acid it increases, because weak acid alone is stable in molecular form. When we started adding base, the dissociation of weak acid keep on increases, so that it is increasing as like this. But after reaching to equivalence point and still we are adding weak base, so that it is also slightly increases as like this. So this is the graph when we take weak acid versus weak base titration. So titration of mixture of strong acid with weak acid versus strong base. A strong acid we are taking as HCl, weak acid we are taking as CH3COOH, and strong base NaOH. So how the titration graph we can observe for finding conductance. So conductance versus volume of base added or alkali, because it is with water. So how the equivalence point. So we are taking strong acid and weak acid. So comparatively weak acid, strong acid will react faster with NaOH. Strong acid here is H plus, which have highest conductance, even Cl minus. So that initially it is having highest conductance value, and slowly it is decreasing, because Na replacing H plus, so that conductance of H plus is less as comparatively Na plus, so that it suddenly drop. And after reaching to equivalence point, after reaching to equivalence point with strong acid, then the equivalence point happens with weak acid, that is CH3COOH, so that it will be like this. So here you should understand carefully. So since CH3COH is weak, so starting less dissociation and suddenly rise as like this. So this is the equivalence point 1. This one is equivalence point with HCl, which is called as 1, and this is with equivalence point of CH3COOH, which is 2. And after reaching equivalence point of both, we are still keep on adding base so that it suddenly increases or rises. That's how the equivalence point happens with mixture of strong acid and weak acid with strong base. So we are adding Ki with AgNO3. Ki plus AgNO3 gives rise to AgI plus KNO3. Conductance versus equivalence point. So volume of AgNO3 added. So here conductance versus volume of AgNO3 added. So Ki is reacting with AgNO3. Here Ag plus replacing Ki. Since the conductance of K plus and Ag plus are remain same, there will be no change while forming AgI and KNO3. Because AgI is precipitate here, so from this no ions are released. So you will get straight line as like this, or parallel to the x-axis. But after reaching to equivalence point, what is the result? Sudden rises we can observe because AgNO3 dissociate more and give more number of ions. That is how the graph when we take titration of Ki with AgNO3. So these are the conductometric titrations in simple way. Let's start batteries. So batteries have a lot of applications in daily life, used in mobiles and used in watches, used in vehicles everywhere. So these batteries segregated into two types, that is primary and secondary. So primary, what it means, primary batteries cannot be reused or recharged again. Reused or recharged. Example for this, Lecland cell are also called dry cell. Mercury cell. Mercury cell is used in watches, that small button battery, and secondary batteries are rechargeable and reusable, like which we are using in the mobiles. And example for this, lead acid battery, most important. Most of the time questions were asked from this. And nickel cadmium battery and fuel cell. So the cell which is used to convert directly combustion energy to electrical energy. So coming to first one, Lecland cell. Is approximately 1.5 volt. So here how it will be. So outside layer is Zn, which act as anode. The inside rod is graphite, act as cathode, and electrolyte is MnO2 plus NH4Cl and carbon black. And what are the reactions happens here we can see. So at anode, Zn converted into Zn2 plus, it undergo oxidation. And at cathode, so MnO2 converted into MnOH. So MnO2 converted into MnOH. Here oxidation state of Mn will be +3, because this is +1, these two are -2 oxygens, so +3. And here oxidation state of Mn +4, so +4 to +3 is increasing, +4 to +3 indicates the oxidation number decreasing and gain of 2 electrons here. It is reacting with NH4 plus and accepting 2 electrons and converted into MnOOH and NH3. So this is the reduction reaction which occurs at cathode. The released NH3 combines with Zn2 plus, which is formed at anode, and make a stable compound which is Zn NH3 taken 4 times. So due to formation of this stable complex, this will not further dissociate, so it is not reversed it. So only this product, once if it forms, the reaction will stop, so that it cannot be reused or recharged further. So that's what the anode cathodic reaction. If you want overall reaction, you can just add the net cell reaction for this. So net cell reaction, Zn plus MnO2 plus NH4 plus. This MnO2 and NH4 is coming from what? Electrolyte, students, which you can see here, converted into MnOOH and Zn NH3 taken 4 times. This is the complex which is formed. And coming to second battery is mercury cell or mercury battery. So mercury cell is having voltage approximately 1.35 volts. So the fluctuations are very less in this, so that it will be used longer time. So reactions at anode. First, what is anode and cathode we can see. Zinc amalgam is anode, HZO mercuric oxide and carbon are cathode, and electrolyte is ZnO plus KOH. What reactions happens at anode? At anode, zinc amalgam reacts with this base and converted into ZnO plus 2 electrons plus H2O, because zinc in zinc amalgam oxidation state is 0. So converted into plus 2, so that loss of 2 electrons. So it is oxidation process happens at anode. And cathodic reaction will be, so cathode is HZO here. So at cathode, what reaction takes place? Next is most important, lead acid storage battery. Most important. So here how it will be, we can see first. This is, next cell is lead acid storage battery. So here cathode is PbO2, lead oxide sponge, and anode will be, this is positive charged, and anode will be Pb negative charge, and electrolyte is 38% H2SO4. Let's see the reactions of this, most important. At anode, oxidation takes place, so that Pb converted into PbSO4 when it react with H2SO4 or electrolyte. So Pb converted into PbSO4 so that oxidation state of this will be plus 2. This will be 0 because SO4 is minus 2 ion. Here loss of 2 electrons, because 0 to plus 2 means loss of 2 electrons. At cathode, what reaction takes place? So at cathode is PbO2 converted into PbSO4. So here oxidation state is decreasing by 2 units. So here oxidation state plus 4, and here PbSO4 is there, so that SO4 and H plus, so you can write it as 4H plus and 2H2O. Here whatever the last 2 electrons are there, that is accepted in this, so that plus 4 converted into plus 2. You can add these two reactions. If you add it, Pb plus PbO2 plus 2SO4 minus 2 plus 4H plus, just we are adding anode and cathode reactions and getting this 2 PbSO4 plus 2H2O. and here electrons whichever that will be cancelled as like this. So here also we can simplify this together. We can write it as 2H2SO4 plus Pb plus PbO2 gives rise to 2PbSO4 plus H2O. This is the reaction which happens during discharge. Discharge equation means when we remove from charging, this reaction takes place. But when we put it in charging, the reaction will be reversed, so that again redox reaction continues. It's like cyclic process. So 2PbSO4, whatever is there, that will be reversed as 2H2O gives rise to Pb plus PbO2 plus 2H2SO4. Here questions are frequently asked, what is the product during discharge, means PbSO4. What are the products during charging, also important. So these are the reactions during discharge and during charging for the lead acid storage battery. So this is secondary battery which can be reused and recharged again. Coming to the next, nickel cadmium battery. So here voltage, in the above case voltage will be 12 volts. Here total 6 cells are there, each cell voltage is 2 volts, so together is 12 volts. So voltage value for this 1.2 to 1.4 volt. And anode cadmium, cathode nickel oxyhydroxide, and electrolyte NaOH. At anode Cd becomes CdOH twice, and at cathode NiOOH converted into NiOH twice. So this happens in branch of 2 electrons. Whichever is released, those are accepted and converting this, plus 2OH minus. Here discharge equation will be just adding both Cd plus 2 NiOH plus 2H2O gives rise to CdOH twice plus NiOH twice. Because electrons get cancelled and getting, this is the during discharge. So coming to next cell, PL cell, the cell which is used to convert directly combustion energy to electrical energy. So this is the dry cell. So this is the PL cell. Alkaline means because here electrolyte is NaOH or KOH, so that it is alkaline PL cell. So which is also written as H2O2 PL cell. And one side anode, H2 gas is anode, O2 gas is cathode. When this react with electrolyte, we get H2O and water. That is the overall reaction what happens here. So at anode, what reaction? These are graphite electrodes. It is having force. At anode, H2 converted into H2O. So here we can balance the equation with 2H2 plus 4OH minus, means which are from electrolyte, and converting into H2O plus 4 electrons. And at cathode, O2, which is cathode, right? O2 combines with the water which is formed at first step or first reaction, and also electrons, and converted into 4OH minus. So this, if you add it, anode and cathode reaction, if you add, what you will get is 2H2, because 4OH minus gets cancelled, 4 electrons gets cancelled, H2O, 1 H2O gets cancelled, and the resultant equation is 2H2 plus O2 gives rise to 2H2O along with this energy. This is how we can convert combustion energy to electrical energy directly. Next one, corrosion is an example of electrochemical phenomena. So how it happens we can discuss. Corrosion, for this example, rusting of iron. So here if we take an iron rod, so iron rod acts as anode. At anode what happens is Fe2 plus converted into, iron rod Fe converted into Fe2 plus electrons. Take 2 Fe, you will get 4 electrons. At cathode, O2, that is atmospheric oxygen, combines with H plus from atmosphere and accept electrons which are coming from anodic reaction, converted into 2H2O. So here net cell reaction, if you see, just we are adding both of them. 2 Fe plus O2 gives rise to 2 Fe plus 2 plus 2H2O. So here what happens, the released Fe2 plus again converted into Fe3 plus over atmospheric oxygen. That means further oxidation happening. So that Fe3 plus means it is reacting with oxygen, so it becomes oxide Fe2O3, which is also written as Fe plus 3. And that Fe plus 3 or Fe2O3 combines with water whichever is released over cathode and becomes rust. The general formula of rust is Fe2O3 XH2O. So this is the rust formation. So here how to make protection of this process, like protection of corrosion or prevention of corrosion process. So there are many prevention methods to avoid corrosion of iron. Those are applying grease or color or bisphenol, and also we coat some high reactive metals over iron. That process called as galvanization process. Iron is coated with zinc. So this is also called as sacrificial protection process. That means zinc sacrificing for iron to prevent oxidation of iron. So Fe coated with Zn. So here suppose if this coated layer removed also, oxidation won't occur for iron. That is very important point. Last year board question this one. So sacrificial protection or galvanization process means high reactive metal coated with lower reactive metals like iron in this case. Even we remove this Zn, there will be no disturbance or no oxidation of iron. That's how it protects from the corrosion. So these are the reactions, very simple. Thank you. So complete electrochemistry I have discussed. If you want to watch, you can watch from first lecture. So it won't take more time also. And I have discussed problems also over this. So don't miss.